Okay, this video is intended to be just an introduction to coordinate geometry proofs. And you can use these examples as you do the examples in class. Okay, so there are 3 steps to any coordinate geometry proof. One is to formulate a plan. So in other words, decide how you are going to prove or show what you're being asked to show. The second step is to use some type of formula, 1, 2, or all 3 formulas, to execute your plan, and then create a concluding statement to justify your proof. Okay, so the formulas we'll be using for coordinate proof are all right here. Okay, they're all formulas from both algebra and geometry, pretty straightforward. And again, I put the formulas here, but if you recall, I had told you with midpoint, think of it like an average. Don't try to memorize a formula. Distance, you can use Pythagorean theorem if you prefer the distance formula. It doesn't matter. But these are the three formulas or concepts you will need to use in coordinate geometry. So let's take a look at the first example. Show that the given quadrilateral is a parallelogram using the given definition or theorem. Okay, so I'm asking you to prove that quadrilateral GRNT with the following vertices is a parallelogram, and I want you to use it using the definition of a parallelogram. Okay, now sometimes I'll leave it open-ended and I'll just let you prove it however you want to prove it. Okay, but in these cases, I'm telling you exactly how I want you to show it. So if we're going to show 2 sets of parallel sides, that should indicate to us that we're going to want to use the slope formula. Okay, and we're going to want to show that we have 2 pairs of sides that have the same slope. Okay, so we'll start by plotting G R N T can't really use a straight edge on my iPad, so forgive me if it doesn't look so nice. All right, so 2 sets of parallel sides. So we want to find first the slope from GR, right? So to indicate your slopes. The slope of GR is, looks like from 5 to 3, so 5 minus 3 over -1 minus 3, which is 2 over -4, or -1/2. Okay, the slope of Tn from -4 to -2 over 6 minus 2. So we have -2 over +4, which is -1/2. Okay, so GR is parallel to Tn. And then we can show GT. The slope of GT, I'm not going to write all of this out, but the slope of GT is, we go down 7 from 5 to -2, and we go up 3, so -7/3. And the slope of RN is down 7 and up 3. So GT is parallel to RN. So our conclusion here is that GRNT is a parallelogram because it has 2 sets of parallel sides. same slopes. Okay, and that's really all a coordinate proof is. So a coordinate proof, I hesitate to use the word proof because it's really more of showing algebraically and numerically that something is true or maybe is not true. They'll get more complicated when we get into more specific types of parallelograms. Okay, so, next page. Okay, so this next one asks us to show that quadrilateral CATE with the following vertices is a parallelogram by showing both pairs of opposite sides are congruent. Okay, so congruent implies the same length. And if you look back at those three formulas, which of those three formulas, either slope, midpoint, or distance, is going to help us with finding lengths? Well, that, hopefully you realize, is the distance formula. So we'll plot our points, -3, 2, -2, 6, 2, 7, and 1, 3. All right, so we want to show that CA and the distance from C to A is equal to the distance from T to E, and that AT is equal to the distance from CE. Okay, so for CA, I'll use the whole distance formula for this one, but after that I will just use the shortcut. From C to A, we have -3 minus -2 squared. It's 2 minus 6 squared, which equals the square root of -1 squared plus -4 squared, which is the square root of 1 plus 16, which is the square root of 17. Okay, so that's CA. TE is, shortcut here, right, from 7 to 3 and 2 to 1. So the distance from 2 to 1 is 1. We'll square that. The distance from 7 to 3 is -4. It doesn't really matter if it's positive or negative because it's a distance. So it's 4, and we're squaring it. 4 squared, and that is still the square root of 1 plus 16, which is the square root of 17. Okay, so we've shown that CA and TE are the same. Now we'll do AT. I'll have to do it over here. AT is the square root of, okay, so we've got the distance from -2 to 2, so 4 squared. The distance from 6 to 7 is 1, so 1 squared. So we've got another square root of 17. And CE is, again, 4 squared plus 1 squared, which is the square root of 17. So AT and CE are also the same length. They actually happen to all 4 sides be the same length, which we'll learn next week is a rhombus. Okay, so a parallelogram that has all four sides congruent is actually called a rhombus. We'll do that next week. For right now, we just want to show that it is a parallelogram. Okay, and the final example I have for you here is a quadrilateral for which we're trying to prove is a parallelogram by showing the diagonals bisect each other. Okay, so if the diagonals bisect each other, this is kind of code for saying they must share the same midpoint. Okay, so for two things to bisect each other on a coordinate plane, their midpoints must be the same. right? Because a midpoint divides a segment into two congruent segments. So if two segments are being divided into two congruent segments, their midpoints must be the same. Okay, so S, -1, 3. E is 2, -1. A is 8, 1. And N is 5. 5. Okay, so we want to show that the diagonals bisect each other. So we want to find out what is that midpoint. Okay, so we're going to use the midpoint formula. Okay, but be careful because we're finding the midpoint of the diagonals, right? Not of the sides. So we want to find the midpoint of SA. Okay, so the midpoint of SA is -1 plus 8 divided by 2. So that's the average of the x's and the average of the y's, which is going to simplify to 7/2, comma, 2. All right, and then now we need the midpoint of NE is 2 plus 5 divided by 2, comma, -1 plus 5 divided by 2, which is 7/2, 2. Okay, so these two midpoints here are indeed the same. We've showed that they share the same midpoint. So Sean is a parallelogram because the diagonals both have the same midpoint of 7/2, 2. Therefore, they bisect each other. I just realized up here on this previous one I didn't write that concluding statement. I should have written a concluding statement that says because CA is congruent to TE and AT is congruent to CE, both pairs of opposite sides are congruent, therefore Kate is a parallelogram. So I apologize, I forgot to do that. Okay, and that's really coordinate proof in a little bit of a nutshell. Okay, feel free to use any of these examples as you do your coordinate proofs in class. And next week we'll do some more extensive coordinate proofs when we learn a little bit more about more specific parallelograms.